In 1864, Jules Verne wrote one of the classics in science fiction. It's a book called The Journey to the Center of the Earth, and it's a story about a group of people who find a passageway that takes them to the center of our planet. When they get there, they find giant dinosaurs and kind of almost a lost world. And it's exciting, it's quite the adventure, and people, they narrowly escape danger. Well, the book was so exciting and it's been such a classic that actually it's been turned into 2 different movies in 1959 and then again in 2008 there's been a Journey to the Center of the Earth movie. Now, going down there and seeing what's the center of our planet has really always been fascinating to people. What's below us? Well, unfortunately there's no giant dinosaurs or giant adventures like Jules Verne envisioned back in 1864. But it's still a pretty exciting place. In this video, we're going to explore what it's actually like if we were able to make it to the center of our planet. We're going to be doing that by looking at 3 different targets. The first thing we're going to do is we're going to identify the major layers of our planet. And then, secondly, we're going to describe each layer and the major characteristics so we can kind of see the difference in how they come together. And lastly, we're going to use some of our vocabulary words. We're going to define tectonic plate, lithosphere, mesosphere, outer core, inner core. Just like Jules Verne, we're going to start from the outside of our planet and go work our way towards the center. The outside of our planet, what you and I see and think of as the ground, is actually something called the lithosphere. Now, I understand in grade school and some other places you might hear it described to as the crust, which is still okay. But now that we're starting to learn more and more about how geologists categorize our planet, we can see that they use the word lithosphere. And lithosphere is actually a Greek word. Litho in Greek means rock. So anywhere you see like a lithograph, which would be a painting that they copied by carving it out and then printing it, which is called a lithograph, or the lithosphere means rock and sphere is ball. So we can think of the lithosphere as the rock ball. Now, a couple things about the lithosphere. First of all, it's solid. Think about if it wasn't. If it was molten lava, well, we'd be sinking. It's a solid rock layer. And in some places, it's extremely thin. In fact, if you were to go to the center of our oceans, down at the mid-ocean ridges, the lithosphere is 0. There's none of it, just at those little areas. Or in other places, it gets pretty thick. If you could go to the top of the Himalayas, you would see actually that it's really about 300 kilometers, or about 200, a little over 200 miles thick. And it's broken into plates, and we call these plates tectonic plates. And it's exactly what it sounds. Imagine taking a plate and smashing it, and you have all these little pieces. Well, that's what's happened with the lithosphere. It's broken into little pieces that kind of fit together to make our crust, the outside of our planet. And there's 2 different types of those. We can have pieces of our lithosphere that are oceanic, so you have oceanic tectonic plates. And there's pieces that are continents, like you and I stand on here in North America. And those are continental plates. And so you put all those together and it makes our lithosphere. Now, we've tried for a long time to actually dig through the lithosphere, to really see what's down below us. And unfortunately, we've never made it. Well, as of making this video, we've never actually made it past the lithosphere. And there's a couple reasons why. We've had a couple great attempts. The deepest mine is a place in South Africa. It's a gold mine called Tautona Mine. And it's only made it about 2.5 miles down. Now, think about it. That's as tall as Mount Hood is up. So that's still pretty deep. And when they got down to the bottom to pull out the gold, the rock and the air is 140 degrees. That's pretty hot. In fact, that's hotter than the weather we get here in Oregon. It's not even hotter than you might find in places like Iraq or Kuwait. It's extremely warm. Not a good place to be. So we can't really personally dig past that. We've had other attempts. The Russians, they tried to dig a borehole. So it's not an actual mine where you could fit, it's just a hole. And they actually made it about 8 miles down. And when they got 8 miles, the temperature of the rock was over 300 degrees. That's an oven. The important thing is that you're seeing is the deeper we go in the planet, the hotter it gets. If somehow we could make it past the lithosphere, we would find the second layer of our planet called the Asthenosphere. If we took the asthenosphere and the lithosphere together, it would be what you learned before as the crust. But we're going to break them apart because they're different. The asthenosphere is also a Greek word. Astheno stands for weak, and obviously sphere is ball, so asthenosphere, weak ball. And the reason that is it's not solid and it's not liquid. It's almost like silly putty, or I almost think of it like maybe Jello. It just kind of, it oozes and flows, but extremely slowly. Kind of just stays there. And the lithosphere rides on top of it, and together they make the crust. Now, the asthenosphere, at some places, is about 100 kilometers, or 60, 70 miles thick, and other places it's much larger, at 700 kilometers thick, or about 500 miles. So it's much, much larger than I would say the lithosphere, but still, compared to the rest of our planet, it's not that large. It's very hot. In fact, if you could get into the asthenosphere, you would see that it's about 2,400 degrees Fahrenheit, or even hotter in some places. It'd be cooler at the top and a little bit warmer at the bottom. And we didn't know it existed until the great earthquake of 1960 in Chile. In fact, it's the largest earthquake on record so far. And they were able to see how that earthquake moved through our planet and detect it using seismographs, and saw that it was slowly bent at this layer that was about 300 kilometers. Turns out that layer that was bending the earthquake waves, the seismic waves, was the asthenosphere. And so it wasn't until 1960 that we even knew this happened. So we're still learning things about our planet. Now, the asthenosphere is still made up of the same things of the lithosphere. So if it's beyond a continent, it would be made of granite, the same stuff that continents are made of, and if it was below an ocean, it would still be oceanic. But if you got past it, you would see something very different. You see, the majority of our planet is made up of this layer called the mantle, or sometimes we might hear it called the mesosphere. And the mesosphere is also a Greek word, just like the other two. Meso stands for middle. So in social studies, you might learn about Mesopotamia, which is between the land between two rivers. Or you might learn about dinosaurs and learn about the Mesozoic age, the middle time. So anytime you see that word meso, you know you're looking at a middle. So the mantle is the middle layer. We've got two below it, or two above it, and we'll have two below it here in a little second. And it is by far the largest layer on our planet. If you could somehow take it out and look at it, you would see that the mesosphere is 2,500 kilometers thick. Now, let me put that back in so you can understand. That's almost 2,000 miles thick. It's huge. So, the mesosphere makes up the vast majority of our planet. And if the top was thick, if the lithosphere was solid and the asthenosphere was like silly putty, this would be like maple syrup. The mantle would be liquid. Now, not flowing like water, it would be sticky, but it would still be kind of like maple syrup and oozing and flowing. Kind of like you would expect to see at a shield volcano, which you can watch at a different video. Now, at the top of the mantle, you would see that it's about 2,500 degrees Fahrenheit. Extremely hot. And if you could keep going all the way down to the bottom of the mantle, it gets to over 5,000 degrees. Extremely warm. And that temperature difference is really important. And you can watch another video called Conduction and Convection, and you can see how that really plays out and why that matters. The mesosphere, or mantle, is also made up of rock called olivine. So if you could actually take out the mesosphere and cool it in your hand, or somehow in super gloves or something, you would see that it would be green. That's not what we think about, but most of the mesosphere is made up of this thing called olivine. If you could somehow dig through the mesosphere, you would find our next layer of our planet. It's called the outer core. And it's pretty thick. It's about 2,200 kilometers, or 1,900 miles thick. It's made up of metal. That's kind of interesting to think about, that it's not rock down below us. If you could dig down deep enough, you'd find metal. But it's so hot, temperatures in some places of over 10,000 degrees Fahrenheit, that the metal is liquid. So underneath us right now is spinning hot liquid metal. That metal is moving around. And anytime you get metal moving around, it generates something called a magnetic field. Now, it's exactly like your magnet you might have on your refrigerator that you can't stick them one side together and they kind of, you can play with around and hold up your nice artwork that you get back from school. But the Earth has a magnetic field. On one end you have a North Pole, and on the other end you have a South Pole. That is what a compass is picking up if you were to look around. It's actually measuring the magnetic field generated by the outer core. It's spinning metal, moving around. Now, that magnetic field does a lot for us. It's actually what channels solar particles that make up the northern lights. It gives us compasses. It also provides birds navigation so they can travel and migrate. It also shelters us from gigantic solar flares that might come and cook our planet and destroy all life. So really, life is dependent upon the spinning metal outer core, the inside of our planet. Now, because it's liquid and because it's hot on one end and cold on the other, it's actually about 10,000 degrees towards the inside and only about 6,000 degrees on the outside only, it creates convection just like in the mantle or mesosphere. And again, watch that video. It's really important that you can understand what convection is. Finally, if we were to go past the outer core, we would get to the center of our planet. Now, we're not going to find giant dinosaurs or giant animals or some crazy adventure. Instead, we're going to find a ball of superheated, solid metal. It's hotter than the outer core, but yet it's metal. It's solid because the pressure is pushing it so tight in our inner core that it turns it solid metal. Temperatures are over 10,000 degrees. We don't actually know the exact temperature, but we do know this. The inside of our planet, the actual inner core, is hotter than the surface of the sun. We think of the sun being so hot and it creates all of that light for us, but actually the Earth's inner core is hotter than the surface. Now, there's hotter parts of the sun, don't get me wrong, but still, that's incredibly hot inside of our planet. Now, just like the outer core, it's also made up of iron and nickel, and it's metal. And it was actually discovered in the same way the Asthenosphere was discovered, by a giant earthquake. We were able to see, we being geologists, not myself, and seismologists, they were able to see that the earthquake waves, the seismic waves, were bent and created a shadow inside our planet. If you were looked down on the opposite side of the planet from an earthquake, you would see that the waves were changed. And based on that, they were able to measure the size of our inner core and what it's made of. So, what did we do in this video? Well, we did three things. The first thing we did is we identified the 5 major layers of the Earth. The lithosphere, the asthenosphere, the mesosphere or mantle, outer core, and inner core. The 5 different pieces. Then we described some of the major characteristics. We said the lithosphere is that solid outer piece that we stand on, broken into plates. The asthenosphere is weak, kind of like silly putty, that the lithosphere rides on, and together they make the crust. The mesosphere is actually called the mantle, or could be called the mantle. It's liquid and is the largest layer and has something called convection in it. The outer core is liquid hot metal, and it creates a geodynamo, which is actually just a magnetic field. It's a giant magnet that helps shelter our planet. And the inner core is our solid super hot metal. Those are the key characteristics. Then we did some definitions. We said that tectonic plates is the lithosphere broken into little pieces. We said a lithosphere is a rock sphere. The asthenosphere is weak sphere. The mesosphere is the middle sphere. And inner and outer core are the centers of our planet. Now, let me remind you how these videos work. You can always hit pause if I'm going too fast, or watch a segment over and catch that again. Or maybe you need to take a break and watch the whole thing over. But always to remember to keep moving forward.